and heartily welcome to our research person, Dr. V. Uma. She is working as an associate professor in the Department of Computer Science, Pondicherry University, Pondicherry. Her research area includes artificial intelligence, machine learning, deep learning, and data mining. She has 30 plus research publications in UGC listed journals, which includes publications in SCI, SCIE and ESCI in text journals. She has 2 published books titled Python Programming and Data Analysis, a beginner's handbook, Programming Concepts in C++, a hands-on approach, and 15 book chapters in edited books. She has attended and published more than 25 international conference publications, and she has won the Best Teachers Awards for the academic year 2018 to 19. Allied with the global medal certificates in the NPTEL course on Python and silver medal certificates in the NPTEL course on deep learning and best papers awards in 2 international conferences. She has 6 PhD scholars. Among 6, 3 scholars were awarded. She is acting as an editorial review board member in the International Journal of Software Science and Computational Intelligence, ICA Global. Once again, I welcome you, ma'am. This session is yours.
Thank you, madam. Thank you, madam, for the introduction. Am I audible, ma'am?
Yes, ma'am.
Yes, madam. Yes.
So, may I know, like, who would be the participants, whether it will be students or a combination of faculty and students, madam?
Mainly faculties and research scholars only, ma'am, here.
Okay, from your university or from different universities, madam?
Different universities. Even from Kerala, Karnataka also we are having participants, madam.
Okay, nice. So, once again, a warm welcome. And first of all, I would like to thank Professor and Head Dr. Shanmugavadivu, madam, for giving me this opportunity. And also, I thank the other organizers, Kalachelvi, madam, and I think one more organizer is there for giving me this opportunity. So with this, we'll go with the presentation. So my topic would be deep learning in healthcare. So can anyone just give a brief idea about what you know or what do you think is the scope of deep learning in healthcare? Any interaction would be better. So anything that you can provide, any of the participant, what you have, otherwise whether you have done some research work in this area or whether you're doing some research work in this area, anything of that sort. Because as we all know, this online interaction is going to be very difficult. So any input that you can give will actually I'll orient towards that in my lecture. Anything of that sort. Is anyone doing a research in deep learning or in healthcare? Anything of that sort? I think some research scholars are there, so you can provide your feedback.
Yes, madam. So here, medical imaging is the main area of research in our department.
Okay.
So here, some of our students are doing developing deep learning methods for medical imaging. And I don't know about the other scholars, those who are attending this. Maybe.
Okay, madam. I understand.
Most of the scholars are working on deep learning applications. Most of them, as madam said, most of them are working on healthcare, medical applications. And 2 scholars are working on agriculture-related applications.
Nice. Agriculture,
plant disease detection.
Okay. That is also very, that is also being widely carried out using deep learning. Okay, good. So I think I will give a brief idea about you are working on deep learning in healthcare. So I'm going to tell like what would be the hope actually, what is the promises that are being made in this field and what is actually not stopping us from applying deep learning in real-time healthcare. I'm not talking about theoretical healthcare. I'm going to talk about real-time healthcare. How difficult is it to apply deep learning for healthcare? So that concept also I'll be covering, and also I'll talk about something about what is the future direction that you have in this area. All right, so with this introduction, let me start my presentation. So any discussion on the topic is welcome. So it need not be a one-way interaction, it can be a two-way interaction. So whenever you find something difficult or when you want to contribute something to the topic, you can very well do it. So is my slide visible, madam?
Yeah, your slides are visible, madam.
Okay, thank you. So what we are going to talk about is deep learning in healthcare, and as you see that I have given a thing like hope, hype, promises, and problems. So what is actually being expected from deep learning, and what is the hype that is being given to deep learning in this field, particularly in healthcare, and what are all the promises that can be given, and what are all the problems that we face when we apply deep learning in healthcare. So I think this presentation will give you a complete idea about deep learning in healthcare. So that is my idea. So first we'll move on to the agenda of this presentation. So first I'll discuss about what are all the types of data that you have in healthcare, not with respect to the general thing. And then we'll be talking about the hope, hype, promises, and problems. And then I'll discuss some literature, what has been done in this medical field, not exhaustively, but to a certain extent I can provide. Because as you see that in your department itself, more number of students are performing research using DL in medical field. So more papers are there, but I want to just show the variations, like what is being done, what are all the diseases that are being taken care. So that way I'll give you some idea. And then I'll get into the what to say, like an interesting topic like precision medicine and IOMT. And then I'll show you a small implementation in Python, maybe to a level, it may be a toy implementation, but just I wanted to show you some implementation in Python using some medical data set. So this will be my presentation. So before getting into what is deep learning and how you apply to the healthcare, I'll just show you what is predictive analytics. As you all know, like you can perform 4 types of analytics. So can anyone tell me? You call that as descriptive analytics, diagnostic analytics. The third one is what we are discussing, that is predictive analytics. And the fourth one is prognostic analytics. Oh, I'm sorry, prescriptive analytics. I'll erase this. Prescriptive analytics. Okay. So in 1960s and 70s, we were talking about descriptive analytics. We were describing what is there in the data using the statistical measures like mean, median, mode, and how we were finding how the distribution is, what type of data is in it, whether there is any outlier in it. So all these of descriptive analytics were done in the earlier stage. And then came diagnostic analytics, like what has happened, why it has happened, what is the reason for such thing happening, why this disease happened, what was the cause of particular disease. So that type of analytics happened. Then came the predictive analytics. So now we are talking about predictive analytics. Predictive analytics is I'm going to predict something earlier, like whether this disease will happen in that particular location or whether this person will get that disease. Is there a chance of getting this group of people? So I'm doing some predictive analytics. That is the third level. That is where we are focusing upon. And ultimately, what we are going to talk finally is prescriptive analytics. Like if I do predictive analytics, then how can I avoid that? Like I say that that person, can he get that disease? So if I know that there is a chance that that person is getting the disease, then what should be done so that he can in be prescription that way, if I put it in medical terms, what we give to that heal from the disease. So these are the various analytics that are being done on any data, right? What medical data, on any data, these analytics have done. So analytics, diagnostic analytics. Now we are focusing on, we are not in 2022. This is happening for the past 20 years. Predictive analytics, focusing on predictive analytics. So, what is predictive analytics? As I told you, like I'm some whether he will this disease, whether how many patients from a particular location having COVID. I'm doing some regression, right? And I'm doing some classification also where he is or not. So that is classification. So this type of thing can be done. Should be doing is like we should have the data with respect to. I am restricting myself. You should have some data. Where will you get the data? You will get the data from imaging devices or spectrography or microscopy. You get the data and you will be storing those data in database systems, and many hospitals may be interconnected, so it has to be stored in network clusters or in hard drives. And then what you should do, you should have the specific computing platforms, right? You should have the proper computing platforms like GPU, CPU, tensor processing unit, cloud systems, distributed systems. So because you have huge amount of data, you cannot store everything in your system. So you need a cloud system for storing it, and you may need a distributed system because many hospitals might be interconnected. So in that case, the distributed computing concepts will be coming. So this should be present. And then, since I told you already that you have large amount of data, then scalability is an important concept that should be taken care, right? So I want to retrieve something from the database or from the hard drive, then proper indexing should be done, proper sampling should be done so that there should not be any delay in getting the data, because as you all know, in healthcare, retrieval of data should be faster, otherwise there's no point in doing a predictive analytics, right? So that should happen. And then after all these things, you'll be designing a model or a predictive model, which will be doing some classification, like whether the patient will get a disease or not, or it will do some regression. It will find out like how many patients will, how many people, how many male or how many people will get COVID in a particular location. So that is regression. Or you will visualize like in a particular area how much of people were infected by malaria, how many were infected by typhoid. So that type of visualization can also be done, and then finally you'll be giving the output. Like what is the output? Whether you have done a classification, regression, what is the output? So these are the different steps involved in predictive analytics. So now itself you will understand what is the complexity, right? So you can see, I'll anyways list it, but now you just think about it. We'll come to that later. So this is what is we are going to discuss in this particular session. So how are we going to go about predictive analytics in healthcare? So, and then finally, I'll finish with how you can go about prescriptive analytics in healthcare domain. So that will be an interesting aspect. So that will come in the final stage of this presentation. So first we'll talk about the input, right? So input, as you all see that you have different types of healthcare data. It is not just one type of data. You have different types of data. So consider you have blood reports, right? So most of the values in the blood reports will be numerical, right? See the different types of data that you have, numerical data. And then you will have medical test results, right? Whether he is anemic or not, whether he is having malaria or not. So that type of categorical data will be there in your report. All right. And there will be other text data also in your medical report. It's not only numerical data. It is not only categorical data. There will be some text data present in your medical reports also. Okay. And then images will be present. Right, like X-ray, you have images. So you need to process those images and do some predictive analytics. So that is again one form of input. And then you'll be having videos also, like it continuous images, like you will be having a CT scan, MRI scan, or ultrasound output. So those are all video type of inputs. And it may be a speech input also, like nowadays you know that we are doing speech recognition systems. So the doctors and technicians will be discussing, they'll be giving some instructions, and now they want such type of systems, like they need doctors need such type of systems. When I was discussing with the doctors, they were telling like, why can't the system recognize what I am talking and directly input that into my system rather than I giving input into the system, like saying that this fellow is having this particular disease, why should I do it? When I tell something, it has to automatically enter the value inside the system that they have, hospital administration system that they have. Okay, so those types of data are also coming. And then signals, right? You have ECG, the signals that get from the EMG machines. So those are to be as input. Type of predictive analytics are to be. So you can see the types of that you can counter in the healthcare domain. It may be numerical, categorical, your speech, signal, so many data it has to you have to handle, right? So if you're doing some predictive analytics, we assume that the data is in text format. Fine. We do some analytics, right? Real world, it is not so. It's not sufficient if you take numerical data or textual data and do some predictive analytics. That is not the real-time scenario. But we people as researchers, we comfortably take the data that is available in UCI or Kaggle, do some predictive analytics and apply our own algorithm and say that my algorithm is performing well. There lies the problem. This is not the real-time scenario. You have to start from scratch. Data to a new form. The size of the data that each hospital is going to have. Or scalability issues are there. So these issues have to be taken care of, applying algorithms or data. But in spite of all these, have some hope applying your artificial intelligence or deep learning approaches on medical in medical domain or on healthcare data. So what is the hope that we have as patients and families? Okay, patients and families, what type of hope they have? They have devices like wearables. We all know, like we have wearables, we have smartphones and tablet apps. And what they are trying is, like, they are trying to provide some health monitoring system. So when you walk or when your heartbeat is somewhat abnormal, immediately some alarm should be given so that some adverse or some risk can be avoided. You can be proactive. So that way, some applications are being developed using machine learning, natural language processing, speech recognition, and chatbots. That is, they discuss with the person. They have chatbot type of thing. It discusses, gets information, and provides some risk assessment. So that is expected, and that is happening, right? And also there are some apps like obesity reduction apps, diabetes prevention apps, and emotional and mental health support. So using some conversational AI, using natural language processing, chatbots and all, they discuss with people and find out how a particular disease can be prevented, or if you have a disease, how can you manage it. So such type of apps have been developed using artificial intelligence. So these are all some hopes, positive things, like, okay, we can develop such apps. Okay, and robotic home telehealth, that is, whether you are following a particular medication or not, whether you are skipping some medication. So in that case, it will give you some messages like you haven't taken your medication, so better take it. And that way you're having some medication management apps also. Okay, I'm not saying that entirely we are not satisfying the healthcare domain. We are doing some apps. The apps are being developed. Okay, and in using robotics, stroke rehabilitation, right? So when a person has undergone a stroke, how can he come out of it? How can he have some exercises so that he'll be back to his normal health? How can he overcome such things? So that type of apps have been developed, and even robots have been developed so that it can help in such for such patients, so that happen, right? To the clinician, what is happening? What type of apps have been developed? What algorithms have been developed? What techniques have been developed using mesh? So you can see that early detection and prediction and diagnostic tools. Where in case of cardiac arrhythmia detection, retinopathy, earlier cancer detection, it is not full-fledged, but to some extent they have you can develop some applications to overcome these things or detect these diseases in earlier stages. Not 100%, but to develop some. And similarly, surgical procedures, you can see that many hospitals, they conduct robotic surgery, remote control centers, and AI-supported surgical roadmaps using machine learning and robotics. And precision medicine, this is what we'll be talking about in the later stage of this lecture. So personalized chemotherapy treatment. Right. So everybody will require a different level of treatment, right? Depending upon their condition. So they don't want a generalized treatment, but to a particular patient, what is advised. So that can be taken care of using this personalized chemotherapy treatment. And here also we have applied machine learning, reinforcement learning techniques to develop such apps or such algorithms rather than apps. Then patient safety. That is early detection of sepsis, right? This has also been taken care. So these are some things that we have developed using machine learning, in particular artificial intelligence. And this much of achievement we have done. It is not that we have not done anything in towards this healthcare domain. We have done, but the level of accuracy matters, right? So that is where we are going to focus upon. Then as a public health program manager, you can see that suicide risk identification using social media. So nowadays what we are doing is we take the social media content and find out whether that particular person is in depression. So how can we provide him some solution so that he need not get into the suicide thought. So that is being done using deep learning algorithms. And then elder care monitoring, you can see that you will be having AI sensors. You will see that what an elderly person is doing at home and whether he's in the risk. So some message can be sent to his relatives so that you can avoid unnecessary complications at home. So that is being taken care of. And also you have some systems that can detect the pollution level in air, thereby finding out what is the probability of a particular disease in a particular location, the water microbe detection. So all these things are being taken care using geospatial pattern mining, which is again a very interesting development that is happening. So taking the spatial data, doing some mining, and even spatial data, applying some learning algorithms, deep learning algorithms, and doing some prediction, right? And then international classification of diseases, ICD, right? So in that area also, like you can see that in foreign countries, they maintain the system ICD-10. And so in some data, that particular column might have not been entered or might be missing. So it is very necessary to identify or classify a particular patient record. So in that case, automatic coding of medical records for reimbursement purposes are being done using machine learning and natural language processing. So this is in particular useful for business administrators. Okay. And then you have fraud detection systems. So you have healthcare billing fraud. So you might be submitting some bills. So that fraud detection should be done, whether it is genuine bill or whether there is some fraud involved in that, and detection of unlicensed providers, whether it is from the licensed service provider or unlicensed service provider. So that is also being done using supervised, unsupervised, and hybrid machine learning techniques. Okay. And for healthcare administrators, what are all the algorithms or what are all the systems that have been developed for healthcare administrators? You can see that automate decisions on drugs, labs, and procedures. So thereby reducing the cost and providing improved quality, and also summarize redundant data. That is, given the data, it has to provide a narrative or it has to provide some summarization. So every this is again being expected from us. They want some system to read the data and give a summary of it, rather than reading the entire. As you all know, like the final discharge summary itself will have so many factors involved in it, and when you need to go through it, it requires a lot of time. And with the current patient load, it is impossible for the healthcare administrators, and so there may be some errors, right? So to avoid that, you can use the text summarization techniques, again using some mining or learning techniques. And then patient scheduling, which again is a very hectic task. So patients will be waiting for a long time. To avoid such delays and also avoid provide more efficient treatment, you can devise some scheduling algorithms and optimization techniques so that it will provide some patient satisfaction, that I went to the hospital and had the treatment in an earlier stage itself, right? So this can also, this is being achieved, and also it needs some improvement, right? So these are various fields. By seeing this, you should be getting some idea towards where you can think of, or if you are in the initial stage of your research, you can think about this. So as researchers, right, what we are trying to do, we are doing trying cybersecurity, because you also in healthcare domain, it is not that you have to work only AI. You can think of security, and you can incorporate machine algorithm and natural language processing algorithm for providing information. So that way also you can, that AI is an individual domain, is actually it has collaborative capability. So you can collaborate with cybersecurity people and find out what is required, and you can develop some algorithms for protecting the personal health information. Yes. Any doubts? I hear some noise. Okay. And then physician management, that like for a particular patient, who would be the best physician? So you can map and find out the best physician that you can arrange for a patient. So that way you can think of some algorithms using machine learning, NLP. Genomics, like analyzing the genes and finding out what will be the possibility of a particular patient, whether he'll encounter tumor or not. So that way you can think, or you can do some disease prediction, like prediction of ovarian cancer using neural networks, or prediction of some other cancer, not only ovarian, using neural networks. And then also you can work on drug discovery and design. Again, you can use the machine learning concept and do some drug discovery, right? So these are all some areas on which you can focus upon. So AI need not be a separate thing. You can apply AI on these things and you can get some good results, and you can provide solutions in healthcare. So having seen the hope, so what is the scope in new job roles, right? I'm doing a research. What will be my future? I'm doing some research on deep learning, and I'm developing some system for healthcare domain. What will be the scope, right? Whether it will be fetch me some jobs or not. So surely you will have much scope. So as a trainer, as an explainer, and as a sustainer, right? What is a trainer means? Like you are developing some systems. In that way, you can contribute in future if you are working on healthcare data. And explainers, you also know that something is happening, the doctors will not understand what is happening through the AI algorithms. Then in that case, you will be work as an explainer, telling them that this is the fact that is being delivered, and this is happening because of this reason. So you should provide some more input. In that way, you can assist the doctors in understanding your system. So that way also new job roles are there. And sustainers, obviously, if you are developing some system, you have to maintain the system. because the new data is coming day by day. You have more amount of data, so your developed system should include those data and provide some prediction. So as a trainer or an explainer or a sustainer, you have more job roles in healthcare domain. So don't think, okay, I'm developing some system, what will be my scope, where can I get a job? So that way also AI is contributing, right? So you know already that more companies are involved in AI related projects, even for healthcare data. So you have more scope in those companies as well. Okay. But what is the hype that is happening? Can I achieve? Because now I told, okay, prediction in cancer, okay, they can do it. I can predict, I can provide cyber security, I can provide diagnostic or predictive facility. So everything, is it possible? Everything I can do it with AI. So that is what people are expecting. Okay, anything you tell, they'll tell like, okay, AI can provide a solution. But is it so? There are some problems. Like, what is a problem that we face? So first we should understand that too in case of healthcare domain. Please understand, healthcare domain is not what we think. It is totally, they are living in a different world. First we should accept that fact. Okay, first with respect to the digital infrastructure, are they compatible? I am saying that I'm going to apply AI, I'm going to apply some training algorithms, whether that is possible in the current hospital situation. So first thing is that. Next is data utility. Right. First, you should understand data present in hospitals cannot be easily taken and some analysis cannot be done. How much of data you can use? How much of clinical data is being captured properly? How much data is being streamed? So that's the question mark. You don't have proper health. So when you have such type of data, only you can leverage the data. You can provide some out. Okay, and we have proper infrastructure, only you will be able to capture the data and you will be able to provide some solutions through AI. So there is a big gap between what is there and what you expect. Okay, and then clinical decision support. I say that I am developing a decision support system, but is it very practical? Can I apply directly on my healthcare data, which is real-time data? Right, that is again a very big question mark. Then patient-centered care. Okay, so patient-centered, it is not that I provide a generalized solution to a patient. Patient has preferences. Can the AI tool provide solutions with the preferences? Can I satisfy the patient preference? So that is again one big question mark. And then community links, right? So you have to provide solutions at community level. It is not one hospital that you should take care. You should provide solutions to a community. Right, and that too in a very responsible and safe manner using AI techniques. So that is again a thing that we should consider, right? And then care continuity. So one hospital is not a standalone thing. It has coordination. It has to coordinate with many hospitals. So there will be a lot of data interchange. You can see the data interchange will be there. So that should be taken care. Right, and then optimized operations. You should provide solutions in a faster way, reducing the resource that are being wasted, less wastage of resources. So you should also take care of and provide optimized clinical solutions. So all these things should be taken care when you are providing a solution using AI. So understand the complexity in it. Okay, so it is not that take some data and provide some solutions. It should be patient-centered. It should satisfy the entire community. It should provide the best in the optimal way. So all these have to be taken care when you apply map AI in healthcare. So this is the problem, right? So why I should go? The people are saying AI will provide. This is happening because there is a huge gap between the actual physicians that are present and the expected number of physicians. So this is the problem. The population is increasing day by day and the number of physicians are not to that level, right? So you can see the difference. In 2034, the number of physicians will be very less compared to the expected number of physicians. So automatically they need some assistance, and that is why we are talking about AI in healthcare. That is the reason that many people are working on applying AI in healthcare data. Okay, this is currently happening, but there are some problems that we have to consider. And see the Indian scenario, right? Doctor to population ratio for Indian states. You can see that the WHO recommended standard is this. But you can see that most of the states are having less number of doctors. Even Delhi, you see the situation of Delhi. Delhi is having less number of doctors. Then you can see that Tamil Nadu, Karnataka, West Bengal, Sikkim are having more number of doctors. But even Delhi is having less number of doctors. Uttarakhand, Arunachal Pradesh, Odisha, Madhya Pradesh, big states are having less number of doctors. Okay, so you can see that in southern side you have more number of doctors compared to the northern states mostly, right? So this is the problem. So now what are the promises, right? What are the promises that are being made? Okay, so these are the promises that are being made. That is, we can provide evidence-based medicine. Okay, so what you can do, if you provide a particular disease, you can provide some solution to it. So I want so collection, summarization. Yes, any doubts? Okay, so this evidence-based medicine is happening, and adverse drug events, that is patient resulting, the damage incurred by a patient resulting from the use of a drug. So what was the drug that was given to the patient? What has caused such a situation? So that type of research is happening, right? So evidence-based medicine is like collection of data and finding out what could be the best thing that is happening for a particular location, such type of generalized analysis, adverse drug events, then healthcare management. So taking the conditions like collecting data from the home and finding out, keep track of high risk patients and design appropriate intervention. So this is also happening using IoT devices. I collect data from patients at home and I am providing some management for those patients. Mostly the next condition and the next one is what we are working. Mostly what we are working is on following on this criteria. Predictive data mining in clinic medicine. That is what we normally focus. We researchers normally focus on this. But there are some other fields also that you can think. Combining IoT and providing some healthcare management. Applying machine learning algorithm and finding out what could happen and provide some solutions. That also you can think. Right. But what we focus is we take some data and then apply some model and do some prediction. That is what is predictive data mining. And medical decision support system, right? So it is not a complete solution, but it will give some assistance to doctors in making decisions. It's not a complete system, please understand. Medical decision support system provides some assistance during decision making. So these systems are what we are mainly focusing upon as computer science researchers. And then passive in-home health and wellness monitoring. Again, this is IoT based system. And then you can see that smart diab. So for in particular diabetes patients, they have done some works monitoring the patients in real time and giving an alert to those patients. You have smart diab. And H-Cloud is again one system wherein it focuses upon how to store the data, how to retrieve the data, give fast access to the patient. So there are different research applications that you can work upon. So there is a hope, there is a hype, there are some promises. So it is up to us to discuss upon what would be the problems. Right. So there is some hope, there is some hype. I understand there are some promises, but you have to overcome these problems and apply your research. So don't think of data that is already there. What is the real problem there in healthcare data? Heterogeneity of healthcare data. So as I told you already, Data is in different forms: images, text, numerical data, categorical data, speech, video. So you have so many data. So if you take a healthcare data, it is not only the blood report. You have to consider the X-ray. You have to consider the scan report. So different data are together. How are we going to process all types of data? That is a big question mark there, right? Voluminous data. So each hospital is having so much of data. How are we going to manage the data? That is again a one big question mark. Change capture. As I told you, change capture. What do you think is change capture? Anybody? Change capture? What is change capture? I hope I'm not troubling you, but if anybody can provide some insight on this change capture.
Ma'am, is it regarding the patient?
Yes, ma'am. Correct. Thank you for your response. So
Okay.
change capture is not exactly what I think you meant is change capture is like with respect to time, his data changes, right? Every patient, when he comes for the next visit to the hospital, the new record comes, right? So your model might be built with your older records. Now new values are coming. Now you have to incorporate that in your model and you have to build your model, right? So that time concept, right? So that is missing. That should be taken care. Okay, it is not that having a set of data and predicting. That every time the data keeps changing, you have to monitor that and update your model based on the new data that is coming. This temporal dimension has to be taken into consideration, right? And then you have noisy, redundant, inconsistent, incomplete. This is widely present in healthcare data. The data is noisy, right? You have some noise in the data. Noise in the sense, even you can see the image in the right hand side, right? There may be some noise in transmission also. I have a data, I collected the data, I take the data, I send it to the hospital, another hospital. In between, there may be a noise added to it. And your new image will look like this. Okay, if you do some prediction on this image, obviously the result will not be good. Then there may be inconsistent data. So some errors will happen when you are monitoring the EEG signals or ECG signals. Your probes might not be fitted properly, so the data will not be correct. So in that case, it may be inconsistent data. There may be a outlier there in your data or incomplete data. There may be null values in your data. Redundant data may be, repeated data may be there in your thing. You have to remove it. So because you have more number of fields, obviously this redundancy will increase your time, right, in prediction. So all these are to be taken care when you consider your healthcare data. And the next one, incorporation of expert knowledge. Again, somebody, if you can give me some feedback on this, that will be good. Incorporation of expert knowledge, background knowledge in data mining. Anybody? Because already I have told you, like, what are all the problems. Already I have given hint. So if you can give me some insight on this point, it will be good. Okay, so I am deciding a decision support system. I am deciding some system, right? I need facts, right? I need knowledge. Who will give the knowledge? Only the experts can give the knowledge. So that is again a very big problem here. As I told you already, doctors are already overloaded. So if I ask them, like, please annotate this data, whether this, I'm giving some facts, whether this patient will have malaria or not, only then my system can learn. My system can learn from what data that you give, right? And that data should have proper input. It should be properly more annotated, right? So that can be done only with respect to with using an expert. So incorporation of expert knowledge is a very big problem. They are not free. They don't have time to do all these things. And if they do it also, it has to be done for the new data that is coming in also. So that is again one more problem that you have, because we are not medical experts. We are only computer science people. We don't know their terminologies. We don't understand what is happening to a patient, right? So they have to provide us input. Then again, this is also efficiency and scalability. Again, this has a relation with voluminous data. But with respect to the algorithm I'm talking. So if you're designing your algorithm, it has to scale. It has to provide efficient output, right? Efficiency. It has to have efficiency in spite of increasing amount of data. So that we should take care. Again, parallel distributed incremental mining algorithm. So this is very important. The algorithm should scale, should provide faster output. So it has to work parallelly. It has to coordinate with different systems and which are interconnected. It has to scale. It has to be an incremental mining algorithm. So that has to be taken care of. And this point, please don't think like this is very least important. This is very important with respect to hospitals. They give utmost care to this point: protection of security, integrity, and privacy. This is a very big thing that we have to take care. Right. So this itself is a very huge task when we are collecting data. This itself is a huge task. So you have to maintain the integrity of data, security, and privacy of data. This is again a very big problem. And imbalanced data. Anybody, can you provide some insight on imbalanced data? Okay, so yes.
Negative cases are imbalanced.
Pardon, ma'am?
Positive or negative cases are imbalanced.
Very good. Very good. So you will get more negative case data from a hospital, positive cases will be less as compared, right? So when you want to collect data for cancer patients, more negative data will be there rather than positive data. So this imbalance has to be taken care. This is again a very big problem. And I think can club these 2 points together. You will be getting more patterns from your system, the modeling model that you are developing. You will be getting more interesting pattern. But how to interpret the pattern, how to analyze the pattern, so how to get useful information from the patterns. Again, you need experts, right? So there lies a problem in analyzing the patterns. And this is again privacy and ethical use of patient information. This is very similar to what we spoke about security, right? So these are the problems that we have to take care. So when you have to address these problems when you are working for a healthcare system, these problems, everything you should take care when you work with the healthcare system. Okay, so what you have to do, I've given in form of a picture. This is not my picture. I've taken it from internet. So this is where the data is. You will have different type of data, from clinical data, from publicly available data sources, electronic health records, patient related other types of data, and databases, healthcare admin databases, everything to be combined, right? When you're providing a solution, all formats of your data you have to build a common data model, and then you have to apply your machine learning algorithm. So you can build a flat file, or you can store it in a data warehouse, build some data warehousing system, and apply some schemas over your data warehousing system, perform some operations. Some operations like in your data warehouse, you have drill down, roll up, roll down. So such operations can be performed so that you can get data, because it's going to be very large data, right? So you have to build some schema on your data warehouses, fetch the data, and then apply your AI algorithm. So please understand, it is not just AI, it involves so many things, and you have to take care of all these things before applying your AI algorithm. So having considered all these things, still researchers are doing some work on AI and healthcare domain. So I'll just hint on some diseases and some methods that have been used. So I'm not getting much into the paperwork and other things. You can see that related to pregnancy, what could be the factors that determine the preterm birth. So they are doing some factor analysis, exploratory factor analysis. And then for breast cancer, some prognosis for breast cancer using some machine learning algorithms. And for cancer, they were using SVM genetic algorithm for feature selection. And then for cancer again, they were using SVM. So, but there lies a difference, right? They were using different data sets and different approaches. And they were even using clustering based classification. So that also they tried. And see that acute respiratory syndrome, SARS, they were doing some clustering, identifying which group of people, which cluster of cases will have such a disease. So they were doing some contact tracing also using these clustering approaches. And then HIV-based database, they were using some algorithms and predicting. And heart disease, and this is diabetes data set, they were they were finding out association rules. So again, a data mining technique. They were using finding out association rules from the data set. And then you can see that they were using some skin disease data set, and they were applying K nearest neighbor, and using pregnancy and liver disease prediction using regression analysis, and heart and diabetes data set, they were using VECA and UCI data set, and Malaysian Ministry of Health, they were considering certain diseases are very data set, 2000 the hospitals directly they collected the records and they were applying association rule money. Okay, and then you can see that they were using other heart related discipline. They were applying naive-based decision tree clustering, multi-layer perceptron, and they were predicting some. They're showing some accuracy. You can see that 99.2, 96.5, 88.3. And again, heart disease prediction, hepatitis, lung cancer. Okay, so okay, I'll finish this and then I'll come back. What is the general observation that you have towards a literature survey that is shown? So drug, they have simulated some data set and shown some results, 23.83, very low accuracy, heart, diabetes, dementia, cancer, and you can see the methods, decision tree, naive-based, neural network, KNN, SVM. So, and again, you can see that they were using for heart, diabetes, and UCI repository and naive-based logistic regression. So, they were applying some machine learning algorithms and they were applying it on certain data sets and they were getting some results. So what do you generally understand from this literature survey? Anybody? What do you understand from this survey? Any observation that you have made towards the literature survey that I have shown? Any observation? So you can see that all are data sets that are already available in UCA. So very few works have been done from the real-time data. So you can see that it is already there in UCI. They don't consider any real-time data. They don't increment, as I told you, right? The data keeps changing, but that is not being considered. And we take some static data, we apply it on our machine learning models and we show some results and we don't consider the real-time factors involved in healthcare demand. So that is the biggest problem when you apply your algorithm in real world data. That is a very big question mark and we have to address that. So any research we do in healthcare domain, we consider all the problems that are listed and solution to that things. So here also you can see that they have taken 146 records from a real-time scenario, but it's a very less amount of record they have considered. As you know, when you apply deep learning, this amount of record is sufficient to prediction, right? So this we should understand. What is the gap between actual healthcare domain and artificial or machine learning models? So what were the tools that this is again one consideration. So what tools did they use? They were using VECA, Mostly they were using Waker. And also nowadays we use other data mining tools like Python, R. You can see Python, R. RapidMiner is again a predictive analytics software. Spark is one that can be used to manage your large amount of data. So these are widely used in doing data mining or machine learning, right? And this is what I told about. These were the data sets that were widely used. UCI, KDD, Kaggle, HIV, this trauma data bank. So see, these are some data sets that are being repeatedly used in the research. Okay, so now we have seen that mostly they were using machine learning. But now, are we not using deep learning based approaches for healthcare applications? Yes, we are using where? So for the blood reports that we already discussed, we are using for classification into normal and abnormal. Again, for your medical test results, we are using classification into normal, abnormal. And medical reports, we take the text data, we do some encoding using word to vec, quantum frequency, or Elmo kind of word embeddings, and then we are providing some summarization of medical reports. So that is happening using DL-based approaches. And X-ray, we do some image normalization, and we are doing classification and segmentation using DL-based approaches. And we are using CT, MRI, ultrasound output. We are doing some slices and frames. We are splitting that into frames, and then we are doing some pre-processing to remove the noise, and then we are applying classification and segmentation algorithms and doing some object detection. We are identifying whether there is any lesion in the images or not. And then for the speech, again, we are converting that speech to text. We are capturing the speech and generate some report using DL-based algorithms. And signals, again, we are converting the signals to vectors, and then we are applying some DL approaches for finding out whether this is going to be normal or abnormal. So these slides give you an idea about what healthcare data that you can use for your research. So these are different types of healthcare data. So you can fix like what are you going to work upon, or you might be working upon this. Okay. So these are some of the deep learning models that are available. You can see that these are shallow models in the sense that regular machine learning algorithms like support vector machine, neural networks, naive-based, logistic regression, decision trees, artificial neural network, and unsupervised learning techniques like K-means. So these are all shallow models, whereas deep models, you can see that deep belief networks, deep neural networks, convolutional neural network, recurrent neural networks, and a supervised learning. And in RNN, you know that you have bidirectional RNN, LSTM, and gated recurrent unit. In unsupervised learning, you have generative adversarial networks, then restricted Boltzmann machine models and autoencoders, which can be used for unsupervised learning. Okay, so you can see that all these models are being now applied on healthcare data. So you can choose which model you want to work upon. Mostly if you want to work on images, you will be choosing convolutional neural network. If you want to work on speech, you want to work on time series data, you'll be using recurrent neural network. Right, if you want to have generation of images, you can work upon, because you might have a noisy image, you want to have a better image being generated, then you can use deep belief networks or generative adversarial networks or restricted Boltzmann machine. So these models have different purposes. So depending upon the purpose, you can think about which model you want to use. Okay, so you want even denoising autoencoders are there, which can remove the noises from your images like scan or your X-rays. So many, there are so many models you can choose depending upon your requirement. So I'll give you a brief idea about what is convolutional neural network. So because I cannot explain the entire thing, but I'll give you just an idea about what is happening in convolutional neural network. So given an input image, I want to identify the features in the image. So how can I identify the features? I want more number of layers. So the initial layers will identify the less prominent feature or less important features or easier features or lower dimensional features, and then it will get propagated to the next level where it can identify the complex features, right? The important features or the high dimensional features are being extracted at the last or towards the last later layers of your convolutional neural network, and it uses the principles of it uses like striding, it uses the concept of convolution, it uses the concepts of activation functions, it uses the concepts of pooling. So after doing all these operations, finally you will get an output depending upon whether you are using what type of disease classification you want to perform, on what type of image you are doing. So this is the general idea about convolutional neural. Okay, so depending upon your image, how much of complexity it has, you will be deciding upon the number of layers and the hyperparameters, like what will be your filter size, what will be your activation function, and you will be showing some outputs. Okay, and in convolutional neural network, you have different models. So you can have VGG model, ResNet, exception net, dense net. Each one has its own functionality. For instance, if you have a VGG model, then it will be more systematic way of designing your filters and size of your images, right? Every time the filter size will be increasing in a very systematic way. So that will happen in VGG model. In ResNet model, you will be having skip connection so that the problem of vanishing gradient will be overcome. And that was designed in 2015. And then came exception models, because you have more amount of computations, like you have to perform convolution operation. And so to reduce the amount of operations, you will be having depth separable convolution, point-wise convolution. So those concepts came into existence, and they designed exception model or mobile net model. And then came dense net again to reduce the provide dense connection and have an improvement on the ResNet model. They designed dense net model. So these are some models that you can use for deep learning. And as I told you, like the data is not going to be only spatially have it not just have spatial dimension, it will also have temporal dimension, right? Because patient records will come one after another, so it has to take care of that. So you can see that I have shown it in that way. Electronic health records, it comes one after another, right? For a patient. So that temporal dimension has to be taken care, and for that reason only we get into recurrent neural network. And there will be a problem of exploding gradient and vanishing gradient. And to overcome that drawback only, will be these models came, like LSTM and GRU. So what is happening is, like, if you have exploding gradient, you can go for gradient clipping and those type of option, and you have back propagation with time. Normally we have this in your recurrent neural network. You can truncate the back propagation so that vanishing gradient problem can be overcome. But still, researchers came with different architectures for RNN, which is LSTM and GRU. Right. So what these architectures, LSTM is long short-term memory and GRU is gate and recurrent unit. What they were doing is they had some gates. All right. And these gates will allow the past information to pass to the next level. So if the gate allows the past information to pass to the next level, so the prediction will be better. It will not consider just the current instance, but the past information of the patient will also be considered in predicting the disease. So that is very important with respect to health records, right? So that is where people started talking about LSTM and GRU. So when considering GRU and LSTM, LSTM is more complex when compared to GRU. More number of gates are there. But if you want to have a better prediction, people normally prefer LSTM. But if you want to have a faster response, then you can go in for gated recurrent unit. So there is nothing like this is better or that is better. You have to apply your own data and find out which model is performing better. And there is nothing like CNN is different and RNN is different. So you can see the combination of CNN and RNN. You can see that I have convolutional neural network, my input is an image. So what I do is first I apply convolutional neural network and then find out what is there in that particular image. And when I have sequence of images, right, then I can take LSTM in combination of CNN. Right. So the same patient will have multiple X-rays and multiple instances of time. So first I will detect what is there in every image, and then I will consider all as a sequence, and I will predict what will be the output. So when you have sequence of images, then you will combine CNN and RNN, and then you can use some prediction. So that is where CNN and RNN can be combined. Okay. Any doubts? Since I'm going a bit thing. Is that okay? All of you clear?
Yes, madam.
Okay. So we also spoke about autoencoders. So as I told you, right, already I gave you a hint of what is autoencoder doing. It is doing because your X-rays are having so many dimensions, and considering all the dimensions is not necessary. So I have to consider only the region in which a particular on which a particular can be made. So dimensionality can be reduced, and to do that we have autoencoders. And also it is not the only purpose, you can go in for noise removal. So you can see that when noise gets added to an image, you can feed it to an autoencoder and you can get a better image from the data. So this is the purpose of autoencoders. And I told you, right, you have models to generate images. And so you can see that when your image is not very clear, you want to generate an image. So that can be done using variational autoencoders. So, so that you can have better prediction. So out of this variational autoencoder, if you feed it to a convolutional neural network, you can get better prediction out of this. So you can club models and you can build your own prediction model. So when you want to have better, variational autoencoders also generate images, but the latent space is discrete. So if you have you can construct a continuous latent space. That is what is attempted in GAN network. So this GAN network will give a CT image, and you can see that it will generate a high dose CT image. Right, and this will actually help in prediction. So that can be done, attempted, or it is being attempted using GAN networks. So it works with the concept of a generator network and a discriminator network. So generator network will generate an image, and discriminator network will compete with a real image. And if it cannot discriminate, it means that the generator has generated a very good image of the original thing. And this will be used for prediction. So that can also be done. And this is again, this GAN is not very different. It is again based on the concept of convolutional neural network only. So here we will be using DCNN, deconvolutional neural network, and here you will be using convolutional neural network. So it's again based on convolutional neural network only. Okay. And deep belief networks, it works with the concept of probability distribution. So it is again restricted Boltzmann machine being connected one over the other. Placing a restricted Boltzmann machine one over the other, you develop a deep belief network. So this is again can be used as both in supervised learning and unsupervised learning. And it is also again used for some prediction task, even Parkinson's disease diagnosis. So, so when you want to work on the distribution of data, then you can choose deep belief networks. Okay. Then this is another important concept. So transfer learning. So if you, so as I told you, like you have models already built for a particular disease, you want to extend that to a different disease. But both the diseases are very related to each other. Then you not build the model from scratch. You can change the later layers of your model, and you can apply it on the new disease prediction, on the new disease that you want to predict. So that type of thing is called transfer learning. And so when you feel that you want to do some prediction for cancer, a particular type of cancer, and you have very less amount of data, Then you can take the model that has been built for predicting another type of cancer, change the later layers according to your own cancer data, and then do some prediction. Because you don't have much data to train your model, then you can go for transfer learning. So this is again a very well, that many research is going on in this area also. You can think about doing a research in transfer learning also. So I'll show some whatever we have discussed. I'll show you like how it has been applied on pneumonia data. So here you can see that they have taken the lung information, X-ray pictures, and then they are applying some ResNet model, and they are doing some prediction. So what we have discussed, right? So they were using CNN, BGG16 exception, combination of inception and VG. So many models are being developed. They are customizing it as per the image they get. That is the idea behind every model. And also they are using transfer learning. So these things are being widely used in pneumonia prediction. PD, blood like hypertension, arrhythmia, congenital heart disease. They take the ECG signals and then they are doing some prediction. And you can see that this is what they have achieved using different machine learning models and deep neural network. So you can see that they are getting good results, not that bad. But again, this is a data set that is already available, not a real world data set. Okay, and the models are RNN, LSTM, GRU, and CNN and LSTM combined together. When they take the signal, process, convert it into a time series signal, apply LSTM. So that way they are combining. Some convolutional neural network model, and then they are applying a fusion also, right? Different convolutional neural network models. They are combining the results and then they are predicting whether it is normal or Alzheimer. So this is a widely used data set for Alzheimer disease. Then again, cancer, so many data sets are available, and they are taking cancer, they are applying convolutional neural network, and they are finding out whether it is normal, benign, or malignant. Again, convolutional neural network is being applied here. And they are also combining Inception V3 with RNN if you want to have a sequence of images. So take images, use CNN, take the features, apply it to recurrent neural network, and do some prediction. And also they are generating images also. You can see that CNN plus variational autoencoders. So they are combining different models based upon the requirement. Diabetes mellitus, again, they are combining DNN, CNN and LSTM based upon your requirement. So these are some other diseases which have been prognosis have been done or prediction are done: hepatitis, infectious diseases, and kidney diseases, right? So input might be MRI, they'll be applying CNN, and they'll be predicting some kidney diseases. So you can see that the amount of work that have been done using ML on healthcare analytics is increasing at large, right? So much of research has been recently done, and that is because you have so many good models being developed in artificial intelligence, and CNN is growing day by day. You can see new models being developed. RNN also is having new models, and the combination of these two is being applied widely. And so there you can see that more publications are being made in this field. But as I told you, you have some technical obstacles. One thing is that you have insufficient interpretability. It is a combination of computer science researchers and doctors. So there lies an obstacle there. And also the images are not coming with good quality, and you have privacy concerns, and you have like the training is not adequate because the data that we get from the hospital is not that clear. It has some noise, it has some incomplete data, redundant data. So obviously the data is less, And so even though they have more data, when we want to apply it to approach, data that we can retrieve from the hospital is less. So inadequate training is what we are trying to achieve ultimately, even though there is a gap between what we are trying is this precision, right? What is precision medicine? The right time, the right patient, the right medicine. This is what we are trying to achieve, right? This is what we are doing for prediction. Why do you want to do prediction? I want to achieve precision medicine. So this is a field that we are focusing upon. Okay, and this is being more focused on Western countries. Already they have done many achievements towards it, but this is in the development stage in Asia and Pacific region. So we are not much doing it, but ultimate outcome of this deep learning based predictive analytics should be this. It should be to precision medicine. But what is happening is we discover some algorithm, we are applying it, we have some results, we don't use it anywhere. We don't take it to the hospital. That is where precision medicine is not happening in Asia and Pacific region. Okay. And this is the holistic integrate. This should happen. This is what I'm telling. This should happen. This thing is what we should thrive upon. So take the data, take all the data, do some processing, extract some information and give it to the knowledge services and data services. This should happen. This is not like taking data and doing something with already existing data. Take the clinical data, take it from the doctors, patients, the sensor data, take the IoT data that you're getting, then do some analytics and give it to the hospital, pharmacy, laboratory and store it somewhere so that you can retrieve it back. So this holistic development should be there in healthcare domain. Okay. And this can happen if you have Internet of Medical Things, as I told you, right? Internet of Medical Things. So medical data, medical equipment should have this ability. It should provide you with information upon which you should apply your algorithm and provide some prediction. So this is what is IOMT, Internet of Medical Things. Okay. So in future, what you should attempt is, instead of assisting the doctors in providing diagnosis, it should transfer to a decision-making system. It is not decision support system. Decision-making system is what we require. So instead of providing auxiliary diagnosis, you should develop a decision-making system. This is what we should aim upon. So these are my references. So you can, thank you. So now I want to show you some implementation. Is it clear? Any doubts before getting into the implementation? Any doubts that you have regarding your research or anything that you want to discuss, please?
Excuse me, ma'am.
Yes.
I have a doubt, ma'am.
Yes.
Actually, can you suggest me a deep learning algorithm for prediction which has input in matrix format, ma'am? For example, gene expression is in matrix format and it predicts some drug score. For that, can you suggest me a deep learning algorithm, ma'am? For prediction?
Yes, ma'am. You can apply convolutional neural network.
It can be used for prediction, ma'am?
Yes, yes.
No,
actually your image itself is a set of pixels, right? The pixel itself will be in matrix form. So it identifies the features only from those pixels. Similarly, you have matrix values. You can apply convolutional neural network and you can get some interesting features from your data and you can use it for prediction.
Thank you.
Any other queries from the participant side?
Okay, so now I'll show you the demo of some diabetes. I think this is a very toy thing that I'm showing. First, I'll share my screen. Not a very big implementation and all, but to show you like how you can apply this, not using deep learning. First, I'll accept that I am not. I'm not showing anything in deep learning. Only with machine learning algorithms that. I have chosen certain machine learning algorithms. Can you see my screen, ma'am? Can you see my Jupyter notebook?
Yes, madam.
Okay. So now what I have taken is I have taken a diabetes data set. I think most of you would have done this, but I want to just tell you like what is important in doing a predictive analytic task. So you can see that I've taken a data set and I'm displaying the shape of the data set. So what do you understand from this 768,9? Anybody? 768,9?
768 rows and 9 columns.
Yes. What are those 9 columns?
Features.
Yes. So I've taken a data set in which there's only 768 records, and understand the problem here, right? So if I apply a deep learning algorithm on this, obviously your efficiency will not be good. You should have more amount of data. That is why I didn't try a deep learning algorithm here. So I have a 768 records and 9 features, and you can see the features here. So the features are like number of pregnancies, the glucose, diastolic BP, skin thickness, insulin, BMI, diabetes prediction, age, and the final column, this is going to be your response variable, that is whether that patient is having diabetes or not. 1 is diabetes and 0 is not diabetes. Okay. So what I am trying is, like, you can see that these are the initial rows and these are the final rows that I have in my data set. So these are all the explanatory variables that you have. So I have 8 explanatory variables and 1 response variable. So totally I have 9. So using these explanatory variables, I want to do some prediction. I want to predict whether a patient will have diabetes or not. So I want to train and build a model so that if I give a new record, right, that is not there in my training, it should be able to predict correctly whether it will be whether the patient will have diabetes or not. So that is what is called as predictive analytics. Okay. And in this, they are giving some explanation, which obviously we will not understand much because we are not from that domain. So this is the description that is being given. Now what I should do, I should first clean my data. I should first find out what is there in my data. Is there any problem in my data before I apply any machine learning model? So I want to find if there is any null values in my data set, and it is giving me that it is false. That is all the data is available. There's no issue in the data, and so the result is false. Then what I should do is I have to find the correlation. You can see that I'm plotting the correlation of the data set. Why am I doing it? As like I have 9 features for predicting my diabetes. Is there any redundancy in my data? Is there any 2 fields that are redundant, or there are more correlation between these 2 fields? That is, if I say that since skin thickness is there, obviously he'll be diabetic. Insulin is there, obviously he'll be diabetic. Whenever skin thickness is there, when insulin is also there, then I need not consider these 2 features. I can drop 1 feature. So I want to find out the correlation between the features. This is one way of doing feature selection, right? So I am finding out, this is again a wrapper based approach that you can, filter based approach that you can try. You do feature selection, right? So these are all things that you need to do before you apply a machine learning model. Okay. So I want to find the correlation, and I find that let me assume that skin thickness and insulin are highly correlated. So I am dropping skin thickness. So you can see that from my data frame, I am dropping skin thickness because I find that it is not going to contribute. So earlier I had 8 dimensions for predicting diabetes. Now I have only 7 dimensions. You see that based on these 7 features only I'm going to predict. I'm dropping skin thickness. Obviously, when your dimensions are decreasing, your time is going to decrease and your prediction accuracy is also going to improve. So this is to be done before you do some machine learning model. Okay. Okay. If there is any data, you should understand that I have to normalize my data set. You can see that the glucose is having a range from 148 to 183, 7. My diabetes field is having 0.6, 0.3, 0.6, 0.1. So again, there will be a problem. If I don't do it, then the convergence will be slow. Finding the result, finding an optimal solution will not happen faster. So you have to normalize it. And so I do some operations to normalize. So that also should be done. And also every value should be done, converted into a numerical value. As somebody told, like a prediction can be done only on numerical values. So I convert the data frame into a numerical thing, and I have every feature as numerical value. Okay. And then I am finding whether there is any imbalance in my data set. So please see this. True cases are 268. How many are having diabetes is 268. False cases are 500. So there is not much imbalance, right? Imbalance means 30, 500 or 50, 500. You can decide upon. If you have imbalance, then you can do some scaling. You can do some smart approaches to upsample your data set. So you can try that. Otherwise, if you are happy with this 34% and 65%, not much imbalance. So I'm going in for my model. So now I'm dividing my data into training set and testing set. So you can see that 69% is taken as training and 30% is taken as test set. Okay. Now I'm doing, okay, I'm checking whether there is any missing content in my glucose. Okay. And you can see that there are some techniques that again I'm highlighting. So if there are missing value in glucose, so I'm using technique for impute with mean. That is, I find the mean value of glucose and replace the missing values with the mean value. So this is again a pre-processing technique. And then I'm applying Naive-Bayes model, Gaussian Naive-Bayes model, and I'm getting an accuracy of what happened. So imagine the amount of coding that I'm doing for prediction, just 3 or 4 lines of code, because I'm importing the already existing built model from scikit-learn. Okay. And then I'm doing the same thing on my test data. So my test accuracy is 74%. Okay. And I'm printing the confusion matrix. Hope you all know what is confusion matrix. So I'm finding out how much is the true positive, false positive, true negative, and false negative. Okay. And then I'm using random forest classifier. Okay. And then I'm finding that the accuracy, test accuracy is, train accuracy is 100%, whereas my test accuracy is 75%. So it may be that it is overfitting. Okay. And then I'm using logistic regression, and I am printing the train accuracy is 73%. And you can see that it's for logistic regression with cross validation. Hope you all know what is cross validation. The accuracy is 70% on my test data. Then I'm using SVM classifier, and I am checking the accuracy of my SVM model. It is 78%, and test accuracy is 73%. So there is somewhat balance here. And then finally, I'm doing MLP classifier, multi-layer perceptron, and my training accuracy is 78%, and my test accuracy is 71%. Okay. And you can see that decision tree I have built. So 100% train accuracy, but only 69% in my test accuracy. Okay. And now I'm trying to plot all my values. I'm drawing the ROC curve, receiver operating characteristic. And I can see that the Naive-Bayes is having a better area under curve AUC that you can derive from your ROC. So Naive-Bayes is better because it has higher true positive rate and lower false positive rate. So it is giving better result when compared to the other models. Okay. So is that clear? Any doubts? So this is a simple data set, and I have taken existing classifiers that have been built in scikit-learn, applied it directly. I didn't do any fine tuning. I didn't do any hyperparameter tuning. I just applied it and got some results. Just showing that it is as simple as this, taking a data set and applying your machine learning models. Okay. Is that clear?